Hello everyone. So today I'm going to talk about classification metrics and I'll be touching upon the cost of different types of errors. The intent here is to build your intuition from ground up so you can appreciate metrics like recall and precision. So for that we are going to take a use case of bank fraud. So imagine you have all of your independent variables like age, education, credit score, and you have your target variable that's your fraud. Yeah. So here one means the case is fraud case, zero means it's not a fraud case. So conventionally, what you'll do is you'll use all of your independent variables to make a machine learning model that will make predictions. Yeah. So we'll not be going into the no machine learning part of it. Rather, we are interested in evaluating the model performance. Yeah. So the first step in analyzing model performance, we disregard our independent variables and we just focus on reality and prediction. So the way we analyze model performance is classification matrix as well as a different type of matrix like accuracy, recall, precision, and F1. So classification matrix is also known as confusion matrix, and you will very soon realize why. But what I want to convey here is this is one of the most fundamental parts on which all of the metrics are calculated. Yeah. So it becomes very important for us to acknowledge how this classification matrix is built. Yeah. So and also there are different kind of terminologies also involved in classification matrix. That's true positives, true negatives, false positives, and false negatives. So if you get confused by these, don't worry. I have a simple strategy to help you understand these better. But right now we'll be focusing on creating these from ground up. So at the base case, all we have is two vectors. One is a reality vector and another is prediction vector. And the first thing that you should do is acknowledge which class is positive. In this context, I have taken fraud as my positive class. Now you may ask, how can fraud be positive? It makes no sense. So do not focus on the word, rather focus on the business implication. Here, finding a fraud case is very much valuable for any business. And that's why, I can justify that fraud is positive for me. Yeah. So first step, you realize there are two cases where the reality is one and my machine prediction is also one. Yes, these two come into this matrix. Before that, let's acknowledge what this matrix is contemplating. Along the rows, you have your reality. Essentially, what is your ground truth? Along the columns, you have your machine predictions. Yeah. So if you can see right now, the highlighted cases are the places where the reality is fraud and my machine predictions are also fraud. Essentially, total two cases which are being contemplated here. Now the point is, how do you what is the nomenclature for them? Yeah. So these are called true positives. And now let's dissect upon how this nomenclature is done. So there are two parts, the prefix and suffix. So first, focus on suffix. What does it say? Positives. This is essentially what your model is predicting. So if you notice, in both of these cases, model has predicted one, which is my positive class. And hence, the suffix part is called positives. Let's talk about the prefix. If you notice, both of the cases, the ground reality was also one, which essentially means in these cases, my machine prediction was actually correct. And based on that correct, I get my prefix that is true, true positives. Yeah, it might seem a little overwhelming as of now, but the moment you see other examples, it will be a lot more clear. Let's move on to the next case. Now there are precisely three cases where the ground reality is 0, aka not fraud, and my machine prediction is also not fraud. Where does this go? Essentially, ground reality not fraud, machine prediction not fraud. So I summarize the number 3, essentially 3 cases where the reality is not fraud and my machine also predicted not fraud. Let's come to the terminology part of it. Now, if you remember, we said suffix contemplates what my model has predicted. In these 3 cases, as you can see, we have predicted 0. Essentially, it is a negative, okay, opposite of fraud. So that's the reason we get negative as our suffix. And did my model predict correctly in these cases? Yes, indeed it did. Yeah, reality and prediction are both the same. That's why the prefix is true. That's how we get true negatives. Moving on to the next case. There is precisely one case where the ground reality is 0, but my machine predicted 1. Yeah. So reality is not fraud, but my machine predicted fraud. What do we call it? Again, what did model predict? Model predicted label 1, which is essentially positives. That's why the suffix part is positive. Was my model prediction correct? Not really. Why? Because the ground truth was 0, I predicted 1. And hence I get my prefix as false. False positives. Finally, our last case. There are two cases where the ground reality was 1, but my machine predicted 0. That too is summarized in this cell. And what do we call this? Well, again, my model ended predicting 0. What is 0? Negatives. Hence the suffix part being negative. And did my model predict it correctly? No. The reality was 1. My model predicted 0. That's why my predictions were wrong and hence false negatives. Okay. So I hope this clears out the false positives, true positives, false negatives terminology. Let's move forward. Now we will focus on the margins. Now margins hold an important place in better understanding of future metrics, and you will soon realize why. Right now, the margin value for this row is 4. It is essentially summing up the values across this row. Okay. So what is this signifying? It is signifying the total non-fraud cases in reality. If you see over here, in reality, there are 4 0 values. Yeah. So it tells me that in my whole data, there are 4 non-fraud cases. Same goes with the 1 value. Again, coincidentally, we had 4 1 values in my reality. That's why 4 total non-fraud cases in reality. Now we will talk about this bottom margin. So if you see in predictions, I had precisely 3 1 predictions. Yeah. So that 3 is summed up over here, which is also actually the column sum. And what is this signifying? It is signifying the total frauds predicted by machine. Yeah. And finally, there are 5 non-fraud predictions by machine, which is again summarized by this margin value. And it is also a sum of this column, basically 3 plus 2. What is it signifying? It's signifying total non-fraud predictions by machine. Yeah. So these margin predictions are very much essential in understanding precision and recall, which will come forward. Now let's talk about the business implications. Yeah. So if you remember, along the columns, we had our predictions, and along the rows, we had our actual values. Now, when you are implementing a model in real time, you do not have the luxury of actual values. You just have input data, and your model predicts that this is a probably fraudulent case or not a fraudulent case. So the business implication boils down to saying that whenever machine predicts non-fraud cases, you would end up giving loan to this person. And whenever the machine predicts fraudulent cases, you essentially say, okay, this is a risky case. I don't want to give loan to this person. Yeah. So now the question is, how do you define model quality? How do you say how good your model is? How can you justify it by a number? And one most intuitive way is to check how many times your model prediction was exactly same as the ground reality. And again, when I am talking about these comparisons, we are moving back to our training arena. Yeah. So this is training data. And what I'm trying to calculate here is how many times reality was exactly same as prediction. So there were 2 cases where reality was 1, prediction was 1, and 3 cases where reality was 0, prediction was also 0. And where are these present in our classification matrix? Essentially, these are your true positives and true negatives along the diagonal. Yeah. So the simplest way to summarize this is saying, total correctly classified cases divided by total cases. Yeah. That is essentially your accuracy. True positives plus true negatives divided by total number of cases. In this scenario, it is 3 plus 2, 5 by 8. comes to around 62.5%. Yeah. But now let's notch up the complexity one level higher. Imagine you have two potential competing models. Yeah, it could be one could be decision tree, another could be logistic regression. So now you have two models, and both of them are making certain predictions. Now, if you see, model one has three true negatives and two true positives, totally five correct classifications. And model two has two true negatives and three true positives. Essentially, both of the models have same accuracy. Yeah, 5 by 8. So now the question is, are these model equally good in business context? On the face of it, it might seem yes, but let's go a deeper level and we'll see what happens. And to highlight the importance of this even higher, the question that you should ask is the cost of all errors same? Yeah. So we are making precisely two types of errors. Yes. One is type 1 error, where the ground reality is non-fraud, but my machine predicts fraud. Yeah. Our false positives. In business context, it basically means that customer was not fraud, but machine predicted it's a fraud. And type 2 error is other way around, where the customer is actually fraud, but your machine says it is not a fraud. Now let's see what's the error associated to these things. I mean, cost of errors. If it was this case, essentially, you would not give a loan to anybody. Let's imagine you have 1 crore of rupees and you do not give loan to that case. Essentially, you lose out on the opportunity to make 15% interest on that principal amount. So the cost of error in case of false positives is 15% of the principal amount. Whereas when we talk about false negatives, this is a case like Vijay Mallya, where the person is actually fraud, but system was not able to detect it. You ended up giving loan to them. Yeah. What happens? You could potentially lose the principal amount along with the 15% interest, thereby magnifying losses by a big margin. Yeah. So the understanding or the key takeaway from this slide is that the cost of errors is not always same. Now let's just put some hard numbers to just get a mathematical number to signify how big that loss is. So as you remember, there was once false positive in model 1, 15% of that, and we are assuming that average loan amount is $1,000. Again, these are just dummy numbers just to help you realize the mathematical part of the complexity. And we have two false positives, and here if you false negatives, and if you notice here we'll be losing 115% of that amount. There are two cases, so 2 times $1,000, essentially giving you 2,300 loss. You sum up both of these values, you get $2,450 of losses. Again, we are just focusing on losses. The profit made from the true predictions is not accounted for. I just want to make it simple for you. We repeat the same procedure for the bottom case. Here there are two true positives, so 15% into 2 by $1,000, and only one false negative, so thereby 1 into 1,000 and 115% of that. You sum up that value, you get loss of $1,450 of loss. So if you notice, the accuracy of both the models is same. So normal intuition says both of the models are equally good. But if you calculate the losses in context of business, you realize that model 1 is making way more losses than model 2. And that's why we need more advanced metrics like recall and precision. Yeah. So to summarize, the business is more concerned about making errors on actual fraud cases. Yeah. Which are they? They are highlighted here in the amber color. So where are these fraud cases being summarized? Remember the margin predictions? That is this value. So I am precisely concerned that out of this 4 actual fraud cases, how many am I correctly predicting? That's why true positives is another thing that I want to be focusing on. Essentially, I want this number to be as high as possible. So recall summarizes this intuition by saying numerator is going to be correctly classified fraud cases, essentially my true positives. And denominator is going to be my total actual fraud cases, which is 4 in my case. This 4 is also can be summarized by saying that sum of false negatives plus true positives, and that's where this formula comes in. Yeah. So now I'm able to connect my business with a metric. I can say 50% of the actual fraud cases were correctly classified by my machine learning model. Yeah. Let's see this thing in action. And by the way, this is recall of class 1 to be precise. While people often use true positives and true negative terminology for recall definition, this label of being positive is very subjective. Quite often, people would consider 0 as their positives, in which case this whole terminology and formula gets complicated to understand. That's why it's better to associate recall or precision with the class labels. Yes. So here I am calculating recall of class 1. Similarly, I could calculate recall of class 0 also. Coming back to the business understanding of recall, most of the things are same. The only difference is this time I'm calculating a recall. So what is recall in this model 1 case? If you can see, there are true positives, and the total fraud cases were 4. So 2 divided by 4, recall is 50%. What's recall for model 2? If you see, there are 3 true positives and out of 4 total fraud cases. That's why 3 divided by 4, 75%. So now recall is giving me a clear indication that this model is way better in classifying fraudulent cases compared to this model, which is also reflected in the loss amount that business makes. Yeah. So now I have a much more clear indication which model is better. Yeah. So to summarize, the cost of false negative was much higher, which was that thus 115% of error. Hence, a model with higher recall is what a business should ideally look out for. Yeah. Just to summarize quickly, what is recall? It is true positives divided by total fraudulent cases, also known as false negatives plus true positives. However, the inverse might also be equally true. What I mean is, some cases, false positives might be very important for business. Let's take example of judiciary system. In judiciary system, the law says it is fine if 100 culprits are roaming free, but you should not put a guilty man behind bars. Yes, that simply means you cannot afford to have false positives. So in this kind of scenarios, we need a different metric. And let's analyze that from our original raw predictions. So here, the question that I want to be answered is how reliable or precise your model predictions are. Basically, if you say a man is fraud, you better be sure it is fraud. So there are 3 scenarios where my model is predicting once. Okay. Out of this, how many times my model is correct? That is what precision summarizes. So totally correct classified fraudulent cases, that is 2 true positives, divided by total false predictions, fraud predictions. And if you remember, total fraud predictions is the margin calculation on this column, which is basically 1 plus 2, 3. So you can see that I made 3, I raised flag 3 times, let's say. And out of those 3 times, 2 times I was correct. That's what precision summarizes. Basically, sorry, that's a typo here. It would be 66% of precision. So now let's talk about practicality. When you are going to build models, when you are doing hyperparameter tuning, you would ideally want good recall and good precision. But the irony is that when you try to enhance the recall, precision takes a hit. When you try to enhance precision, recall takes a hit. There is a trade-off kind of thing going between them. So ideally, you want one metric that can summarize the importance of both of these metrics. And that's where F1 score comes in. So F1 score is a harmonic mean of recall and precision. Yeah, 2 times precision into recall divided by precision plus recall. So basically, F1 might be a good metric if you do not want to keep a tab on multiple metrics. Okay, so that's pretty much it from my side on classification metrics. Hope to see you next time.